Okay, for 32, find you got to find a parametric function now that's going to talk about the full circle, radius 2, centered at 1, 2, starting point 1, 4, traveling counterclockwise and clockwise. They want the time interval down also, all right? That makes it more problematic for me. So I'm going to go back to the whiteboard and start talking about what they just told me. Get my pen out, and let's talk about that. So I'm going to draw a little picture. This is the x-axis. This is the y-axis. And what they tell me, it says, the circle radius 2, centered at 1, 2. Let me put this over here. So 1 and then 2 up. So the center. And this helps me out with the problem. You don't have to write this down, by the way, because it's already written down. And they tell me the radius is 1. So I know the equation of the circle. It's going to be x minus 1 quantity squared plus, let's see what we get over there, y, let's see, minus 2 quantity squared is equal to r squared. And what's r? Oh, I'm sorry, r is 2. What am I saying? How do I know that? It says it's 2. That's how I know that. All right. Let me draw my circle, and so I'm not saying it's the greatest picture in the world, but sort of like this over here. That's my circle. Right. So that's going to be 4. All right. So it's easy for me to, talk about what I have to do now, and what I have to do now is I guess I have to, make sure I understand what the circle is in terms of sines and cosines now. And I do have a relationship for it. And the relationship there. I know Pythagorean relationships over here. Let me write this over here. So x equals r cosine theta. Do I know the radius of a circle? I do. The circle is radius 4, right? And do I know, I know y. What's y going to be? Y is going to be equal to r. Oh, by the way, I'm not saying in the original problem, just my relationships I know about, sine theta. But when I plug these things in here, if I did that, I'd have a problem there. And what I got to do is I got to add 1 to this over here, because I got to make this to be, certainly r cosine theta, and I got to add 2 to this one over here. And again, the reason I want to plug these in here, and I want to make sure it gives me back the 4. All right. Let's see if that does that. I'm going to check it out now. So what do you get? Let me write this down. R squared cosine theta. I'm sorry, not r squared. Yeah, r squared, I'll put that down. Plus, if I plug the next in the y in, what do you get? You would get r squared sine squared theta. And that should equal our radius squared. Let's see if that's true. What do you get over there? Well, gee, you get r squared comes out, and you get, cosine squared theta plus sine squared theta is equal to r squared. So that makes sense, all right? So now I'm gonna write this over here. X equals, well, what's the r? It's 2 cosine theta plus 1. And then I'll put the y equals 2 sine theta plus 1. All right, so x is a function of theta. Let's put a down. X is a function of theta. Let's put this over here. 2 cosine theta plus 1. And y is also a function of theta, and that's going to be 2. You know what? I just realized I made a mistake in copy. Glad I'm paying attention. Didn't look right. That's plus 2. So that's going to be 2 sine theta plus 2. Now, by the way, I need a time interval. And this requires me to think. All right? I'm going to go back to my picture. And I know I didn't do a very good job over here. I'll put maybe something a little bit better down over here. And I know my pictures are terrible, by the way. But they want to start at the point 1, 4. And initially they want to go this direction over here, which is counterclockwise, right? That's actually a little bit easier for me to deal with. So I got to get a starting position that gives me 1, 4. Right? I got to get the starting position that gives me 1, 4. I'm kind of looking at it. I'm going to say to get that to be 1, 4, right? So x of what theta would give you 1. Well, looking at it, I'm going to say pi over 2. Now, x at pi over 2 is equal to 1. And let's make sure y of pi over 2 is going to give me what they said, which is 4. And that does work, by the way, because the sine of pi over 2 is 1, 2 plus 2 is 4, right? And then what happens is, as I start to move through this over here, this thing's going to start to move in this direction over here, right? And then the question is, how long does it take to get around? Well, let's be careful about it, all right? What I mean by careful about it, I want to talk about, let's see what we're going to talk about first. And I guess I have to think about this for a second. And it's always a problem with thinking. I got the x, I got the y, and I'm gonna have to move around. I know it goes from pi over 2 to some number that's bigger than pi over 2. And let's just think about that. Let's just think about the x values. So the x, if I thought about it, I said I was going to start at pi over 2, right? And I'm going to say the cosine there would be 0. Then the thing sort of goes down, comes back up, comes back down over here. And it's going to hit that position again over there. All right? Now, where does that occur? That looks like it's going to be 2 pi plus pi over 2. All right? So this is going to be A. And let's go to B now. Now, B's more difficult for me, believe it or not. It's still going to be the same parametric curve. So x of theta is going to be equal to 2 cosine theta plus 1. And y of theta is 2 sine theta plus 2. That's still the same thing. All right? And then I gotta start starting at a different position now. And I have to think. And that does take some thought. So I'm going to cross this out. And I want to go in the other direction. And I'm going to say it has something to do with minus theta now, because I want it to go in the opposite direction. And let me write this down over here. So 2 cosine, I'm going to say minus theta. But again, I'm wondering about this over here. Plus 1. All right, and let's be really careful what we're saying over here. And by the way, I want to use the same time interval. But this is going to make it go backwards here. I still want to use this interval. Okay, I got to be really, really careful with this. And to look at this thing over here, let me get my eraser out. This takes me time to think through it. And let me, you know what, I put t there. I should have put it, I keep mixing things up. I think in my notes I might add a t or theta, I can't remember. I'll look back over it later. But I got to be more consistent with my choice of letters. All right, let's put this down. And I'm going to try to do it. So let's put this down. I'm going to multiply both sides by minus 1. So minus pi over 2. Minus theta. You know what? Going in the other direction, so I got to change the direction of these things too, right? That's a problem, isn't it? Minus 2 pi minus pi over 2. All right, let's just rewrite it a little bit differently. And I'm going to put down minus 2 pi So already a little bit neater. Minus pi over 2. Minus theta. And that'll be minus pi over 2. All right. I'm going to add something to all three sides to make it the same thing as this over here. I think it's 3 pi. I'll still check it when I write that down, by the way. And what do you get there? Well, you get pi minus pi over 2, which is pi over 2. That's success. Over here, what do you get? 3 pi minus theta. And then what do you get there? You would get, oh, you get 2 pi plus pi over 2. All right, so I got the same thing. All right, now I have to write that down now, and then we'll look at the k. So, whoops, this is the angle. Let's write that down. I get my eraser out. I need to put that, underline that. So x of theta is going to be 2 cosine 3 pi minus theta plus 1. And y of theta is going to be 2 sine 3 pi minus theta plus 2. All right, what I'm going to do is I'm going to go back to the actual notes and see how we did. First things first, I'm going to look at A. I know so using t, it's fine to use t or theta, whatever you want to use doesn't. Oh, you know what? I should use t because it's about time intervals. And let me go through that and get my my eraser out. So everything is time. So every theta I see, I'm going to erase and put a t down instead, because they did say time intervals. Let's do the second one. I'll do that one. Start to make some erasures. And I'll erase this over here. Erase that, that, and put the t down. All right. So let's take a look. And, oh, you know what I got to do? I also have to write the time interval. This is not, although it's true, it's not what I want to write down. So what I want to write down is, you know, this thing is really equivalent to this thing over here. It's the same thing, by the way. We just went through that. All right, so the time interval here is actually pi over 2, t, 2 pi plus pi over 2. All right? Okay, so let's go back and I corrected the t's in the problem. Let's go back to this and see if we got the right answer. So what's A say? A says x is equal to 2 cosine t plus 1. I got that. It says y is equal to 2 sine t plus 2. I got that. What's time interval given me? Pi over 2, t, I see that. Yeah, we did okay there. Let's do the next one. Let's look at B. Let's see if they wrote this down. I'm looking for this over here. Did I write that down? 2 cosine 3 pi minus t plus 1. And this one over here, 3 pi. Yeah, I got that. And the time interval is identically the same. All right? Thank you.